So I think, I don't know if people noticed it in the video, but there's no real limit to how many levels of tunnel you can have. So you can go much further deep than you can go up. The deepest mines are much deeper than the tallest buildings are tall. So you can alleviate any arbitrary level of urban congestion with the 3D tunnel network. This is a very important point. So a key rebuttal to the tunnels is that if you add one layer of tunnels, then that will simply alleviate congestion, will get used up, and then you'll be back where you started, back with congestion. But you can go to any arbitrary number of tunnels, any number of levels.
But people assume traditionally it's incredibly expensive to dig, and that would block this idea.
Yeah. Well, they're right. To give you an example, the LA subway extension, which is, I think it's a 2.5-mile extension that was just completed for $2 billion. So it's roughly $1 billion a mile to do the subway extension in LA. And this is not the highest utility subway in the world. Yeah, it's quite difficult to dig tunnels normally. I think we need to have at least a 10-fold improvement in the cost per mile of tunneling.
And how could you achieve that?
I guess, actually, if you just do two things, you can get to approximately an order of magnitude improvement, and I think you can go beyond that. So the first thing to do is to cut the tunnel diameter by a factor of 2 or more. So a single road lane tunnel would, according to regulations, has to be 26 feet, maybe 28 feet in diameter to allow for crashes and emergency vehicles and sufficient ventilation for combustion engine cars. But if you shrink that diameter to what we're attempting, which is 12 feet, which is plenty to get an electric skate through, you drop the diameter by a factor of 2 and the cross-sectional area by a factor of 4. So, and the tunneling cost scales with the cross-sectional area. So that's roughly a half order of magnitude improvement right there. Then tunneling machines currently tunnel for half the time, then they stop, and then the rest of the time is putting in reinforcements for the tunnel wall. So if you design the machine instead to do continuous tunneling and reinforcing, that'll give you a factor of 2 improvement. Combine that and it's a factor of 8. Also, these machines are far from being at their power or thermal limit. So you can jack up the power to the machine substantially. I think you can get at least a factor of 2, maybe a factor of 4 or 5 improvement on top of that. So I think there's a fairly straightforward series of steps to get somewhere in excess of an order of magnitude improvement in the cost per mile. Our target actually is, we've got a pet snail called Gary. This is from Gary the snail from South Park. I mean, sorry, SpongeBob SquarePants. So Gary is capable currently he's capable of going 14 times faster than a tunnel boring machine. Okay.